Okay, so let's take a look at this acceleration mini lab. Normally, we would actually collect data, but due to the nature of the way that we have to run things this year, I'm just going to simply give you the data in advance. So here's what we have. We have a ball that is going to be rolling down a rather long ramp. And what we want to do is we want to look at the position versus time graph, or D versus T, and we want to compare it to the V versus T. But of course, the trick is to develop the data to generate the V versus T from the data that what we were given, which is our positions versus time. So for part one of the procedure, we're asked to calculate the change in time values in the space provided on the chart. So I gave you a little sample calculation here, but if we look at the chart itself, basically I've got it set up so that it's fairly easy to be able to do with the alignment here. So if we're looking for this delta V here, forgive me, delta T, not delta V. If we're looking for this value here, as you can see, this cell here straddles these two spaces here. So it's going to be this number minus that one. So it's going to be 1.00. For this cell here, it's going to be the third minus the second trial. So that's going to be your 2 minus 1. And then when we look for this one here, this will be your third trial, your fourth trial minus your third trial, which is going to be this minus this, and so on and so forth. So then you fill in all the way down here for all of those values. For part two, we're asked to find the change in position, or the distance covered between those time intervals. So the formula is here. It's your final position minus your initial. And it's really more or less the same thing that you were asked to do in the previous one, but simply we're just now working on the change in position column. And we're going to be doing much the same thing. We're looking for the change in position between trial 1 and trial 2. So it's going to be this value less this value, or this value minus that one. So in this first cell, it is going to be 0.50. Then we find the difference between trial 3 and trial 2. So that would be 2 minus this 0.5, and that would be 1.5, and that would go in this cell. And you continue on all the way down. Now for part 3 of the experiment, we're asked to find the V values in the chart using the formula provided. And this is the formula that I'm referring to. So you're looking for the delta D over the delta T. So literally, these values that we calculated in part 1 and 2 is what's used to get this value. So it's going to be whatever is in this column divided by this one here. And that's what will give you your value here. So the delta D divided by the delta T. And then you just keep going on. So for this value, it'll be this number divided by this number over here. And we just keep going all the way down, just like we did with the others. Now, number 4 is very important. And the reason why it's very important is because when we graph the speed versus time, or the velocity versus time, it's going to be different times than we do for the D versus T. So we're looking for the time for the center of the interval. So to calculate that, that's your T1 plus your T2 divided by 2. Basically, it's the average. So let's take a look at this one right here. We're looking for the average of 1 and 0, because that's your trial 1, your trial 2. So that would just be 1 plus 0 divided by 2, and the halfway point would be the 0.5 seconds. Many of you will probably see a pattern at some point. So on the next one, it'll be between trials 3 and 2. So the halfway point basically between 2 and 1 is 1.5. You can probably do that in your head, but mathematically that would be 1 plus 2 divided by 2, and 1 plus 2 is 3 divided by 2, 1.5. Easy peasy lemon squeezy. So again, this would be 0.5, this would be 1.5, and you can probably guess the next one would be 2.5, so on and so forth, and we work our way down. So next, when we have to graph the D versus T, it's how you draw the curve afterwards that's mission critical. The values we'll be graphing, this will be your Y, this will be your X. Now, just making a very, very rudimentary sketch. Normally, you're used to getting straight lines, but in this, you're going to probably see something more like this. So if we were to graph this, if you notice, it actually isn't really it's not making a straight line. It's actually making a curved line. And here, I'm going to exaggerate that last one. If it looks like the points are curving, then what you are to do is follow what's called the curve of best fit. So I'm certain you've remember the term line of best fit, but here we're looking at the curve of best fit. So you best try to find the trend as best you can. Now, the key for these things is to try to do it in pencil. Of course, very difficult for me to do it on the computer, but you'll see a bit of a gentle curve. You'll see a bit of a gentle curve here. Now, for the next graph, you have to be careful. This one, the second graph, is going to be much easier to draw, but you have to make sure you do V versus T center. All right. It has to be center. So you're not going to be graphing at the 0, 1, 2, 3, 4, 5 second mark. It's going to be at the 0.5. Sorry, try that again. The 0.5, the 1.5, the 2.5, et cetera, et cetera. And that's where we go with that. That should be enough to get you started.